So next up, we're going to have Laura Bates, a PhD student from the University of Wisconsin-Madison, presenting in person.
All right, thank you for attending. So I'm very new in my data analysis right now with my research. So you'll get to kind of see what's been going around in my brain last few weeks. So I've got some remaining questions and would love to hear your feedback too at the end if you have any suggestions or ideas. So this is just some preliminary data and some background on my dissertation. Okay, there we go. So in an effort to manage non-point source pollution in the dairy state of Wisconsin, the DNR passed some phosphorus standards for surface waters. And the criteria I'm most concerned with is 75 micrograms per liter for surface water streams. And Green Lake is where my research is housed in. So the watershed is located in about south central-ish Wisconsin. The shoreline has a lot of primary and secondary residences. It has a heavy agriculture watershed, which is about 65% of the drainage area. And it also supports a lot of outdoor recreation. And 41% of the water runoff that feeds into the lake comes from, well, surface runoff and from the 8 tributaries. So it has a high potential for nutrient transport from that agricultural watershed. In fact, it was listed as impaired in 2014 for hypoxic conditions and high phosphorus concentrations. And it's been dealing with ongoing issues with nutrient management today. And of course, we all know this is an issue across the Midwest. So why am I so focused on Green Lake? Well, like the rest of the state, it's supported by both recreation and agricultural economies. So it's a nice mini representation. It has the unique position of being the deepest inland lake in Wisconsin, so not including any of the Great Lakes. At its depth, its deepest depth, it's about 236 feet. So it has some added challenges of legacy phosphorus settling to the bottom. It's hard to remove, and it's particularly difficult to manage. And often these two economies can be in political opposition with one another when it comes to nutrient management needs. But in this watershed, it's a great case of them actually working together. We have stakeholders like the DNR, USGS, watershed management agencies, rural landowners and farmers all working together to meet some of the water quality goals of this watershed. An example is Project Clean Streams, which is a lot of stream restoration and planting riparian vegetation to help clean up some of these pollutants. These are funded by agencies like USGS, but they're largely in part implemented by volunteers from the local community. So it's a great way to get everybody involved. And most of these projects have been completed between 2012 and 2018. This map shows just kind of a spread of where these projects have occurred at each of the tributaries that feed into the lake. So everything in green and magenta has had 20% or more of its stream sections restored. And then everything in yellow or yellow orangish has had minimal to no restoration projects. And this isn't really a good or bad thing. It's just a distribution of the spread. It's obviously not necessary to restore all sections of all streams. But in the case of Silver Creek, for example, it's the largest tributary that feeds into the lake. It's the most heavily impaired, and it drains 63% of all of the agriculture that goes into the lake in general. So it's an ongoing issue and certainly needs to be looked at. But of course, stream restoration projects are very expensive and they require a complex knowledge of the ecosystem, in which case we have a lot of ongoing monitoring of water quality and biological species. The DNR has a surface water integrated monitoring system, or SWIMS database, that houses all of this data that researchers, volunteers, they can input the data and anybody can access it. But, water quality monitoring and biological monitoring is great to have. It's important to also understand what is the actual association between the two. How are these biological data responding to these nutrient pollution? And if you're going to ask for funding for future restoration projects, it'd be nice to know if they're improving and they're actually, are they doing what they're supposed to be doing in the watershed? So this is just the spread of my sites. I collected data over 2 years from 2021 and 2022 at 14 sample sites. 6 of those sites were strictly, or where I collected biological data, but I collected environmental data and water quality data at all 14 sites. Biological data include diatoms and macroinvertebrates, both of which are sensitive to changes in their environment. So they serve as great indicators for stream and biological condition. I collected diatoms over 2 summers and macroinvertebrates over 2 fall seasons. And at the time of biological sampling, as well as all the rest of my sites, I've collected water samples, as well as the usual suspects of environmental data, dissolved oxygen, pH, things like that. And this is just a lab visual of my own analysis, which includes total phosphorus analysis, which was conducted by the AQ2 robot you can see in the middle picture there. So focusing in on this first research question, what is the association between stream biological species and pollutants in some of Green Lake's tributaries? You can see from this graph here, we have diatom species counts with total phosphorus concentrations at each sample site. That red line indicates the Wisconsin state total phosphorus threshold. And this includes data from 2020 to 2022. I collected data in 21 and 22. From 2020, that was obtained from the SWIMS database that I mentioned earlier, just to have a little bit more information here. And you can see diatom species increase with increasing total phosphorus. Diatoms are algae, so it's not too surprising. So one of my next steps will be to develop an index score with diatoms so I can identify many more factors going into this besides just species counts. And then looking in the fall, I did develop index scores for macroinvertebrates based on the presence of sensitive species. So we have macroinvertebrate index scores with total phosphorus at each sample site. Again, that red line is that state threshold for total phosphorus. And that green line is the threshold for a good index score based on DNR protocols. So you can see kind of, for the most part, they're doing pretty well up until maybe about 0.2 milligrams per liter of total phosphorus before they start petering off a little bit. I would like to have more data to see if there's actually a trend going on here and if that actually is a definitive concentration we should be concerned about. And then the next part of my research will be to investigate whether these restoration projects have improved these biological conditions or nutrient concentrations in the streams. So this is fall macroinvertebrate index scores over 3 years at each of the 6 sample sites I've collected. And again, that green line is that threshold for good. This is a case for, you can see sites 10 through 14 and 5 have had a lot of restoration done. Sites 8 and 9 have not had any restoration done. They've all been increasing for the most part over 3 years. Site 8 in particular has increased quite a bit, and Site 9 has consistently remained above this threshold. So if you want to see a visual of those 2 sites, it's pretty clear they don't really need a lot of riparian vegetation planted on those sites. But does that necessarily mean if the invertebrate index scores are doing well, that nutrient concentrations are low? But as you can see here, not really. These are summer total phosphorus concentrations at each site. Site 8 and 9 are circled there. And the red line is again that state threshold. Everything to the left of that gray line has not really had any restoration projects. Everything to the right has had much more significant restoration projects. So maybe just looking at these 2 years in the summer, you can see restoration seems to do a good thing for the streams. They're quite low compared to the non-restored sites. But when you look at the fall, it's a lot more gray area. It's not as obvious that restoration has actually been improving, especially in that 2022 year. And of course, you might be thinking, what about rainfall? Does that affect it? Well, I'm thinking that too. So that's another thing I'm going to ultimately look at is 5-year data trends, if not more, whatever I can find from the SWIMS database and elsewhere to supplement my data to account for that seasonal variability. And I had mentioned that restoration projects had been completed from between mostly 2012 and 2018. So that'll give me a good spread since 2018 to see if there's been any improvements. Perhaps macroinvertebrates respond faster to restoration projects than nutrient concentrations. That's another question to address. So just kind of looking at my remaining questions and next steps. What are 5-year trends? I, of course, want to make diatom index scores and not just look at their species counts. I'm going to compare to other environmental data as well. I collected total nitrogen samples. I just didn't include it in my presentation today because I'm still working through that analysis and Wisconsin doesn't actually have a state threshold for surface water total nitrogen yet. So that might be something I want to look into. Right now, it's more narrative criteria, like this amount leads to this issue, but there's no like standard threshold yet. And so hopefully some statistical analyses will help me kind of determine maybe there should be one for Green Lake, and maybe these total phosphorus thresholds are statewide, but should the thresholds be the same in a area like Green Lake or Madison or Milwaukee or way up north in like the north woods of Wisconsin? Maybe they should be more region specific and less statewide specific. But ultimately, I'm hoping all of these answers to my questions will come with the statistical analyses. And my data is, or my research methods are designed so they can be applicable to other watersheds too in Wisconsin or the Midwest as well. So I welcome any feedback, questions, and ideas, and thank you for attending my talk.
We have time for a couple of questions. Reminder to the online folks that you can type your questions in Huba Q&A.
Hi, good job. Thank you for your talk. You may have mentioned it, but you did, and I apologize if I missed it. But what are the types of restoration activities that are being done for the sites that you presented data on?
Yeah, most of them are riparian vegetation planting. A lot of the streams have been converted more towards agricultural land, so they're kind of restoring, adding riparian vegetation back rather than what has been removed. There are other BMPs, of course, like within the agricultural watershed. I just focused on within the streams themselves. And they are starting to actually have some new technology that collects nutrients from the agricultural field directly, and then it can be removed. So there's a lot of stuff going on with that. But restoration's kind of been like the recent thing that they've been working on.
Great, thank you.
Any other questions?
Yeah, really cool talk. And I'll start by saying that as a former Wisconsin resident, I caught my largest northern pike ever at Green Lake.
Wow.
The thing I was going to ask you about is there any differentiation between particulate phase phosphorus and dissolved phase as far as like, I mean, there's big differences in terms of bioavailability, but do they differentiate that in terms of, I mean, maybe not in the measurement, but in terms of how you guys are looking at it?
Yeah, obviously the particulates that settle are the biggest issue, more so, less so the dissolved. So that's where I'm focusing more heavily on, but my total phosphorus accounts for just both. But I think just because the research is so heavily focused on what's being settled, it's a little less, or not negligible, but it's not as big of a focus on the dissolved quite as much, at least in terms of this specific stuff. But yeah, it's definitely things I'm considering, and also breaking apart total nitrogen too, and figuring out which components, if any, are heavier than others, or is it just all of it together? So is it, total phosphorus and total nitrogen, or individual components of those that are affecting things? So definitely things I'm considering too for future analysis.
Thank you. I may have missed it, but what's your rationale for using diatom as your biological indicator?
Yeah, I have looked at a lot of literature that talks about how it's like used in all freshwater systems, but it's not as widely used as an indicator like macroinvertebrates and fish are. So I'm just trying to like kind of play with some new things. I think it's an up and coming method of analyzing biological indicators. And so it's just been kind of a new approach to looking at it. And it's also recently been looked at in the Green Lake Watershed, and I'm trying to like kind of pick up that momentum and continue with it.
Thank you.
Thank you.